Hello and welcome to another Pybricks tutorial. Here we're going to use our Spike Prime robot and learn how to make it drive forward, backwards, and turn using the Pybricks block coding. While we're here, please notice that our left motor is plugged into A and our right motor is plugged into B. Right. In the code, we can go ahead and click Create New File, give it a name. You'll notice we can't have any spaces in here. It gives me an error message. Can't click create. If you click fix for me, it actually fixes it. Adds a little underscore in between. I can click create. Over here, we can go ahead and set up our robot. Setting up our robot, we can select the prime hub. We can select two motors. Right here, set up smart motors. Grab the second one. I'll go ahead and give my motors a name. Left motor, right motor. You'll notice that there's a port that we could add in right here, where we could say on left A port, and right is B port, and then the default value is for which direction it wants to drive in. I'm going to go ahead and say that this default needs to be backwards, and this one needs to be forward. This is just for the configuration of my robot. Let's go ahead and take a look at the setup again. We'll need to grab one more thing, and this is the drive base. Go ahead and select the drive base and add it to the setup section. Inside drive base, I'm going to go ahead and give it a name. Let's give it a name like this, Jeff. And then you'll notice here it's trying to set up the different motors that's going to be used in the drive base. So left, it's going to be the left motor. That's why I gave it such a name like left motor, identifying name. Then it's going to be right motor, right, not left motor, right motor. So Jeff is going to use on the left motor side, left motor, and on the right motor side, right motor. Over here we can look at additional setups that we need to set up our motors. So here is the wheel diameter. So let's go ahead and take a look at our robot. Our robot, right here, has a wheel diameter. See, I'm going to use some calipers right here. A wheel diameter of about 55.7. Yeah, looks like 55.7 is the value I'm getting from over there. So I'm going to go ahead and add that into my code and say 55.7. Right on. Right here we also have the axle track. So this is going to be the point where we have our wheels from the middle point over here to the middle point of our other wheel. The distance in between this is our axle track. Now, it's trying to figure out where exactly is your wheel touching the ground. It's from that point where it touches the ground to the point where it touches the ground on the other wheel. That's your axle track. So it should be, using the spike wheel since they're a little curved right here, right in the middle of our wheel. So I'm going to go ahead and take a look at my wheels and use the calipers again, and it should be around 125, 126. But here, let's take a look at a more accurate way to find this value. I'm going to go ahead and find here, this outside width is 140.8. And I'm going to go ahead and find the size of one of my wheels. This is going to be 114. 114.3 ish, or not 114, 14.3. Yeah, about 14.3. And what we should be able to do is take the one of these wheels. If you split it in half, right, it's going to be half of this wheel, half over here. We should get 126.5. Taking the distance here, taking the size of one of our wheels, and 126.5 should be the size between the point to point right here, which is around about right here, and that looks pretty accurate. So I'm going to take this value right here, 126.5, and I'm going to add it over to the code. This is for our axle track. 126.5. Now your robot's definitely going to be different from mine, so make sure you try to get a super accurate value for this. This value is important for when we're turning our robot. This value is important for when we're driving forward, and it also trying to turn too. Let's go ahead and get into driving forward and turning. Over here inside the program section, we can see we can go ahead and remove this hello Pybricks section for it's a print for the console. Let's get rid of that. Let's go ahead and go into the output. And in the output, you'll notice that there's motors. These are for singular motors and adjusting values for single motors. If we drive down or go down a little bit right here, we have drive base. Let's go ahead and grab this first block that says drive straight for 250 millimeters. You'll notice here that it automatically took the name Jeff that we gave the drive base. Jeff is going to drive straight for 250 millimeters. So if I click start on this, let's go ahead and see what's going to happen to our robot. So I'm going to click start. Oh, oops. Our robot drove backwards. Can you guys figure out why it drove backwards before we move on to it? Why is my robot driving backwards? In the code, looks pretty good. 250 millimeters, that's driving straight. It's actually how we set up our left motor and right motor. This one should be this way, and this one should be that way. So now, if we go ahead and take a look at our robot again, and we click play, perfect. Our robot's now actually driving the intended direction. Amazing. So, this is how we have our robot drive forward. So, we just told it to go 250 millimeters. Let's go ahead and say we want it to go for 150 millimeters, which is about right here. You can see this. Switch over to the camera. You can see this 150 millimeters is about this distance. Alright, so from where the center of the wheel is, right here, and I click start, and I change it to 150 millimeters. I click start over here. It's now going to go ahead and drive 150 millimeters. See that one more time. I can actually click start from here now that I've downloaded it. And the robot is actually driving 150 millimeters. Perfect. Alright. Inside the code, we can go ahead and add another drive straight, copy, paste, and we can have it drive straight. If we put a negative in the front of the distance, it's now going to drive forward 150 millimeters and then drive backwards. Let's go ahead and take a look at that happening. Right. If your robot is not actually getting to the 150 millimeter zone, your diameter of your wheel, where you set it up, is probably wrong. So if it is not getting to the right spot, you might need to adjust this value over here, up or down. Alright, let's go ahead and take a look at how we can have our robot turn. Delete this guy. And on this menu right here, click drop down, it shows us a bunch of different ways. So we can drive forever, but we're looking for turn. There's 3 different ways we can actually have our robot turn. Turn in place by a given angle, curve by a given angle and radius, and then veer along a circle for a given distance. Let's go ahead and take a look at turn in place by angle. Jeff is going to drive a turn by 90 degrees. The robot is actually going to know the heading, its heading, using the axle track and the diameter of the wheels to calculate how it's going to get to 90 degrees. So if we go ahead and leave this here at 90, go over to our camera, we can set up our robot. Our robot should turn 90 degrees to the right. Now this is all using those setup values for our diameter and our axle track. This is what it's using to calculate these values. If we go ahead and add, say in our code we wanted to go negative 90, it's now going to go negative 90, which is to the left. Positive, negative, negative 90. Let's go ahead and do positive 45. Positive 45 should have our robot turn 45 degrees. Again, if your axle track is not correct and your wheel diameter is not correct, this value is not going to be 100% perfectly 45. So you're going to have to tune that. Alright, let's go ahead and take a look at different ways that we can have our robot turn. So this is turning in a given place. That meant that our robot was turning around a point from in the middle of our tire to the middle of our tire, right in the middle, that spot right around here. That's where it was turning around. You can see that right there. Let's look at different ways that we can have our robot turn. So if we take a look over here, we can see that we can have our robot also turn curve by a given angle and radius. Curve by a given angle and radius. So over here, we have a radius and a degree value that our robot's heading wants to end up. Alright, 100 radius and 90 degrees. What does that mean? Let's take a look at the robot. If we take our calipers and say 100, we can use this 100 to figure out the radius from the middle of our robot, that point where it was turning around earlier, in between where our axles are, so right in the middle of our wheel. We can say 100, and that's about right around here. Our robot should turn, with this point staying in the same spot. This is going to turn, and the middle of our robot should end up right around here. We go ahead and click start. Yep, and it ended up right around there. You'll see that this is in line over here. Our robot ended up going around this point from here to here. This is 100 millimeters. And it's coming around this point. We can go ahead and increase that value. So let's go ahead and look at the code. Let's go 200. Or let's go 150 because my calipers don't actually get to 200, so we can actually confirm that this is correct. 150. Looking at our robot, make the calipers go 150, right around here. Middle of our robot, around there. Then our point that's going to be traveling around is right around here. These more here. If I click start on that position, our robot should follow this arc and end up right around here. You'll notice that the distance between here stays the same all the time. Let's go ahead and click start. 150, turn by 90. And it ends up this being the same. Robot's facing in this direction, 90 degrees. And this arc, this curve, was correct. Alright, let's go ahead and look at the final method of turning, which is veer along a circle by a given distance. This will now also have the radius, so let's go ahead and have this radius be, again, 150 like we just had it. But now, instead of saying we want the robot's heading to end up being 90 degrees, we can follow the circumference, the perimeter, the outer, like the line of the circle, and say how far along that line do we want to travel. So you can do a little bit of math and figure out 250 millimeters along that circle. Let's go ahead and take a look at what that's going to look like. So I'm going to keep this 150, 250 millimeters along that perimeter. Let's see, 150 was around about, here. I'm going to go ahead and click start. And we're following around that perimeter. I'm going to make the value now be, let's go 100. So we're traveling around that perimeter 100 millimeters. It should be less. Yep, that's about 100 millimeters along that perimeter. Thank you so much for following along with our Pybricks tutorial. We're going to have a ton more content coming at you. Please stay tuned. Don't forget to like and subscribe, and we'll see you in the next one. Bye-bye.